Hello, so today's video, we're going to differentiate the function ln, the natural logarithm of the modulus of sine of x. So we're going to differentiate this function. Clearly, it's going to be an example where we need the chain rule to differentiate it because we're taking a function of a function and we want to differentiate such function. So yeah, what we need to kind of remember in order to do this calculate this derivative, is that when we differentiate the natural logarithm function with respect to a variable, we get 1 over x. And when we differentiate the modulus of sine of x, so this is what we did in the previous video, literally my last video yesterday, is we differentiated this modulus of sine of x function. And the result we got when we calculated this derivative was the modulus of sine of x multiplied by cot of x. So we got that result from yesterday, and that's going to be helpful in today's video here. So again, we're going to need the chain rule to differentiate this, and we've done plenty of chain rule examples before in these videos. So we're differentiating the natural log of the absolute value of sine of x. So using our chain rule formula, so using the chain rule formula, what we're going to do is we're going to differentiate the function itself. So ln of the modulus of sine of x, but with respect to the modulus of sine of x, we're differentiating with respect to this absolute value there. And then we're going to multiply that by the derivative of the absolute value of sine of x. And we're differentiating this with respect to x. Okay, great. So now if we do this first derivative here, well, we know that differentiating the natural log of a variable with respect to such variable gives us 1 over the variable. So this is actually just going to give us 1 over the modulus of sine of x, like so. And then when we differentiate this modulus of sine of x with respect to x, we know from the previous video that we got that. And so we should just get the modulus of sine of x there, like that, multiplied by the cotangent function, cos of x. So what do we notice now? Well, the modulus of sine of x there and there just cancel out like so. And so we're just going to be left with cot of x. So when we integrate the natural log of sine of x, we actually just get the cotangent function, cos of x. So yeah, let's summarize this on the next page. So differentiating with respect to x, the ln of the modulus of sine of x function actually just gives us the cotangent function of x. And let's just consider where this function is valid for. So this function is only going to exist if this sine of x value is a real value. So you can take the natural log of only positive numbers. The absolute value inside the log function there needs to be positive, but of course it is positive, apart from when sine of x is equal to 0. So when is sine of x equal to 0? So sine of x equals 0 when when x is a multiple of pi. So when x equals n times pi, where n is an integer. And so therefore, this function is undefined, this derivative is undefined. So derivative undefined when sine of x is not is equal to 0. Yeah, so derivative is undefined when sine of x equals 0. So in other words, when x equals a multiple of pi. Otherwise, it doesn't matter what x value you put into the sine function, you'll get a number different from 0. And take the absolute value of that, you get a positive number. Log of a positive number is a real existing value in the real numbers. So yeah, so we've got to make sure that sine of x does not equal 0 in order for this derivative to exist. And that's the end of that video.